The scientific process. In previous science courses, you may have been taught that the scientific method is an orderly series of steps followed by scientists, something along the lines of observation, hypothesis, experiment, conclusion, with some variations. The possibility of multiple experiments, rejected hypotheses, other steps in the middle, but basically linear. Science doesn't really work that way. There is no prescribed order of steps which guarantees scientific success. There are characteristics of science, which were discussed in the Characteristics of Science slideshow. But the method of doing science is variable. There are, however, unifying elements. Look at the center of this chart. Gathering data is central to all of the sciences. Hypotheses are formed, predictions are made, and experiments are conducted. What constitutes an experiment varies from pure observation, think astronomy or meteorology, to carefully controlled lab work, and things in between. Once data has been collected, it could support or contradict the hypothesis. Or be a complete surprise that leads in entirely new directions. Where ideas come from and what is done with the information once it has been collected varies from field to field, and even within fields. But sharing within the scientific community is always part of the process. This includes peer review, replication by other scientists, publication, and/or presentation at scientific meetings. Discussion with the community often leads to more questions, and then it's back to hypotheses and testing. So, what is a hypothesis? It is a possible answer to a scientific question. Note, it is a possible answer, not another question. Also, it is not a guess. Hypotheses are based on background knowledge and previous or preliminary experiments. What makes the original question and the hypothesis scientific? They must be testable. When testing hypotheses, scientists are trying to disprove them. An analogy might be building the strongest possible wall. How do you know it is the strongest? Try to break it. If you can't, it may not be the strongest possible, but it holds up for the moment, until a better wrecking ball is built. Similarly, scientists design experiments to try to show their hypotheses are wrong. If they can't disprove a hypothesis, then that hypothesis is the best explanation for the original question so far. Frequently, scientists can think of several possible answers to a question. Experiments are designed to eliminate one or more, leaving the best current hypothesis. Hypotheses are tested over and over with different experimental designs and by different scientists. Those hypotheses that are not disproved are accepted, always leaving open the possibility of new evidence. The word theory is used differently by scientists than it is by the general public. Many non-scientists use the word theory to mean someone's idea about something, the way a scientist might use the word hypothesis, or even wild guess. But for scientists, a theory is the best current explanation for a body of data. It is not just one tested hypothesis, but an integration of multiple hypotheses. If there are multiple competing theories, the best one is the one that explains the most data. Despite the general public's use of the term, theories are not guesses. In order to be considered a theory, An idea must have been tested multiple times and have lots of data backing it up. But as always in science, we must be open to new data. While it is highly unlikely that a well-established theory will fall completely with the results of a single experiment, pieces of theories are frequently revised, and certainly hypotheses that are part of a larger theory can be disproven. This is why scientists always hedge their bets. They say things like, "Our best evidence suggests that." If you are looking for absolutes, science isn't the place to find them.